The prime factoring way first, guys. This is a more difficult question. So, if you guys look, we have a lot of numbers here. Okay? So I'm going to show you a shortcut to breaking down variables instead of doing the tree way. We're still going to do the tree way for 21, 28, and 7. Okay? It's called a factor tree. You guys remember from elementary school. So, I'm going to do a factor tree for 21, factor tree for 28, and a factor tree for 7. And then I'm going to show you guys quickly how to do the variables without having to do the trees. So, 21. Factors of 21 are 3 and 7. And luckily, 3 and 7 are prime numbers. I can't break 3 down anymore. It's 3 and 1. And I can't break 7 down anymore. So I'm already set there. 28. Well, I can do 2 and 14. Or I could have done 4 and 7. Doesn't matter. We're still going to end up at the same answer. 2 I can't break down any farther. So you know what we're going to do? We're going to underline our final answers. So 2 is the final. I can't go any farther. Well, I can break 14 to 7 and 2. If you look at that, 7 and 2, those are both prime numbers. And finally, 7 can only be broken down into 7. Okay? So, the numbers I've underlined, I'm going to replace the above numbers. So 21, I'm going to replace with 3 and 7. 28, I'm going to replace with 2, 7, and 2. 21 was 3 and 7. And I'm going to replace 7 with, well, just 7. So, I'm going to rewrite this question. Actually, before I do that, we're going to take a quick look at our C and our D for the first question, and I'm going to apply that to all of them. The best way to break up C to the power of 4 is just to write C 4 times. Because C times C times C times C, it's going to be C to the power of 4. So whatever the exponent is on the variable, just know that I'm going to write that variable that many times, okay? Instead of having to actually break it down into a tree, I'll show you quickly how C4, yeah, the explosive, C4, that can be broken into C squared, which can be broken into C and C, C and C. Well, those are primes, and look at that. I have C written 1, 2, 3, 4 times. If I just look at the exponent, I can just know to write the variable that many times, okay? So that's a trick when we're doing the prime factoring way to do this. Dude. Our new question, when we look above, we're replacing 21 with 3 and 7. I'm writing C 4 times. And I'm going to write D 3 times. So that is 21C to the power of 4, D to the power of 3. That's in its prime form. Look how many numbers we had to multiply to get to that. Okay? That's why this way can become tedious after a while. 28 is going to be 272, and it's C, oh my gosh, D to the 5th. 2, 7, 2. And how many C's and D's do I got to put? 2 C's, 5 D's. Okay. 1, 2, 1, 2. I hope I have room for this. 3, 4, 5. And finally, we're left with 7 and, is it a lot? A little? Oh, thank goodness. C and 3 D's. I think I can fit this. C and 1, 2, woohoo, 3. Okay, we fit it all in one line. No, that is very expanded. In fact, that is the most expanded form you could have of any numbers, okay? Now, it's a little confusing. We're going to play the pairing game. But this time, because there are 1, 2 operations, I have to find that number in all 3. Okay? So I'm going to go through them quickly. Is there a 3 in all of them? Whoops. No. So I can't circle a 3. Is there a 7 in all of them? Yes. So I can take a 7 out. Here we go. We're taking 7 out. Taking 7 out. I got to take it from all 3 this time because there's 3 numbers. Okay? And is there a 2 in each? In all of them? No. Okay. Now we're getting into the C's. I know there's a C in each, so I can circle one value of C for each number. Are there 2 values of C in each one?
Yes.
No. Can't do any more C's. Let's move on to the D's. I know there's a D of each. 1, 1, 1. In fact, there's 2 D's of each. 2, 2, 2. And how many are there in total? 3. 3, 3. So, there we go. Let's take a look at everything we've taken out. I've taken out 7 C and 3 D's. So, on the outside of my brackets, I'm going to have 7 times C times 3 D's. So before I keep going, I just want to simplify that. What's that going to look like on the next line? Yes, 7C D to the power of 3. That's what I took out of everything. Now, what's left? I just have to write what's left in all of these. So I have a 3, and I have 3 C's. 1, 2, 3 in our first term, right? Yeah, that's right. Subtract. I have a 2, and a C and 2 D's. So you got to stay organized when you do this way. And then the last one, I took everything out of the last one. So what do I replace it with? 1. Okay? So now, what is 3 and 3 C's going to be? 3C cubed. What's 2 times 2? 4. So I put the 4 down. C and then D squared and subtract 1. Okay? So that will be our that is our factored form of this question. Sorry guys, that's supposed to be a addition sign, not a subtraction sign. So in the end it should be +1. Okay? That's the prime way. You're going to have to do the greatest common factor way because we don't have time. Kind of like that TV show. Oh, we're all out of time. I think that's Sesame Street, actually. All right, you guys okay with this?